Coming up next on This Week in Radio Tech, Grady Moates is with us, first time with us. If you don't know Grady, you should. Amazing engineer. Loudandclean.com is his website, but he's here to talk about HEBA. What is that? We'll find out next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support online at bgs.cc. By the Ruby Console from Lavo. See Lavo in your future at lavo.com/TWiRT. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by the CalRec Type R console system. Type R is a brand new, modular, expandable IP-based radio system from CalRec Audio. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to the light bulb at the top of the tower. I'm Kirk Harnack, your host. I'm here in the Telos Alliance studio in Nashville, Tennessee. Thanks a lot to the Telos Alliance for providing me a little bit of time today to do the show, a little bit of near the end of the workday time, and also some equipment here. We got plenty of Telos gear right here in the racks. More back in the back. Got a lot of stuff here. Hey, our show is also brought to you in part by my friends at Max Connect, maxconnectwireless.com. That would be Josh Bone at Bone Broadcast. And what does this box do? It's full of antennas. Look at that. It's brimming with antennas. This is loved by all the engineers who are using it. It's just amazing. This is a data modem. It connects to one or the other of two wireless carriers. And here's the deal. It doesn't just give you 4G data. I mean, anybody can do that. Your phone can probably do that. This has a higher priority than you do. It has a higher priority than your phone does. It has a higher priority for data than all 80,000 fans in the football stadium have. That's right. That's because it has basically just the one click under the data priority of first responders. It's that good. Your data gets through. There's special channels set aside for the services that Josh Bone has created at Max Connect. We've done video through this from the NAB show this past spring. I did the SBE membership meeting live. We streamed it live. And my phone, my T-Mobile phone, as good as it is, and I love it, wouldn't pass the video properly. It was a lot of spurts and sputters. This did it just fine. There are monthly plans available for different amounts of data. You could use this for remote broadcasts. You can use this for a backup for an STL. You can use it for a full-time STL if you need to. You got to pay for some data. But check it out. You go to Max Connect Wireless. And yes, it's all spelled funny because you know how the internet is. All the good names are taken. MAXXKONNECT wireless.com. We'll put the link in the show notes, and you can check it out. I am really excited about this and glad to have Josh Bone and Max Connect Wireless as a sponsor on the show. Chris Tobin and I will be doing some of our shows with Max Connect Wireless. No more ketchup bottles for Chris. And if you're a longtime fan, you know what I'm talking about. All right, we've got a great show coming up for you, and I'm delighted to bring this to you. And I'm delighted also to bring you Grady Moates. Grady and I met years ago as in his capacity as an audio processing expert and also as, I think, a tower site owner in the Boston area. Grady, welcome into the show. Glad you're here.
Glad to be here. Thanks for the opportunity.
Well, tell us a little bit about, let's see, we met maybe what? Hey, wait, we were at a trade show. You came and helped me wrap up a trade show, as I recall. That may have been the first time we met.
As a matter of fact. Oh yeah, it was over, and somebody had to put that stuff away, and I had nothing else to do.
Your engineering career began somewhere in the South many years ago. Tell us about a little bit about the early days of Grady Moates and broadcast engineering.
Okay, Daddy gave me a Allied Night Kit radio broadcaster amplifier when I was 11. I built it. It worked. I put it in the corner of my bedroom and played DJ till I was 15. And then I actually got myself a job at the local radio station in, I can't even remember now where it was, but it was West Florida, Chipley, Florida. Station no longer exists. Just doing nights and weekends. And then I was a DJ. And I did that for about 15 years. But I discovered that there were these folks that showed up with toolboxes and worked at night, and they were making a lot more than minimum wage. And I realized that I was as a DJ, not ever going to be able to make much more than minimum wage. And I knew how to do electricity, and I just stepped over and never looked back.
My goodness, that is a similar story for a lot of us. Holy cow. It's also been, before we get to our first actual commercial, and I got to tell you, the show is about not just Grady and his audio processing talents, but about this antenna design that has got some incredible advantages, especially for AM stations in these days when real estate becomes very valuable and AM towers tend to take up a lot of real estate. We will get to that. But first, Grady, tell us a little bit about the audio processing expertise and how that came about in your life.
Well, I don't want to call it expertise. I was just, like I say, I was a DJ and I wanted my stations to sound good. And if I wanted my turntables to start fast and my microphone not to have hum in it, I had to learn how to do that myself because it cost too much to get the engineers into these small market stations from the big city. So I learned how to, adjust an audio processor back then. I am nowhere near the expertise of anybody who is involved with Omnia, for instance. But I can hold my own, and that's basically it. Let's see, 1978, I was in Washington, D.C., and I lived near Alexandria, Virginia, and the Patent and Trademark Office was 3 miles away. And one night I was chemically enhanced, and I said, if I'm going to be doing work on the side as Grady Moates Engineering, nobody knows what that is. But I said, why don't I name my company what I do? And I looked it up, and there were 14 different things that were doing loud and clear for a patent or, for a trademark or a service mark. But nobody had loud and clean. And in broadcasting, that's kind of more what you do. Yeah. So I drove over there and filled out the forms, and the rest is history. Everybody wants to know why I'm 71 years old, and I just paid to renew it for yet another 10 years. And it's literally because of this antenna that I've been helping to develop. I don't want to have to change my email address.
So there you go. And you're right. Loud and clean doesn't have to apply strictly to audio processing. It's the whole chain, including the antenna.
Absolutely.
All right. Hey, we're going to hear about the this antenna in just a minute here. Our show, This Week in Radio Tech, is brought to you in part by my friends at Broadcasters General Store and the Broadcast Tools Pro Mix 4. Now, the Pro Mix 4 is so cool. It's something that you need to look into if you do a lot of remote broadcasting. The Pro Mix 4 is actually a mono audio console. Huh? What? Well, if you're doing a simple remote, you probably don't need the extra hassle of plugging in stereo stuff. You're going to use a mono console. You can also use it, by the way, as a great little mixer for a voiceover booth. The Broadcast Tools Pro Mix 4, though, is meant to go on the road. It's super easy to use. The knobs are easy. The buttons are easy. It doesn't give you a lot of options, but it does exactly what you need. So it's got 3 mic inputs, but they're also line inputs, mic or line. They've got those slick Neutrik connectors, that have the 1/4-inch plug in the middle and the XLR plug around the outside. It's got a built-in USB codec, so you can just hook it to your laptop and you can feed audio from it to your laptop like that. So it stays digital. Or you can use the laptop as a source back into the Pro Mix 4. It's got a mono balanced line level output. It feels weird here in 2019 to be bragging about a mono line level output and a mono line level input too, by the way. But if that's what you need, if that's going to make it simple, if that's going to make it so your disc jockey can go out there and plug it up, hey, how valuable is that? It also does have a mix minus output. So you know what mix minus is. You need that to do phoners and codec stuff. It has an LED audio output level VU meter, full duplex talkback capability. That's cool. It's got IFB audio input with level adjustment, and it's got an on-air tally warning light relay output. That's what all the cheap consoles don't have. Things like a little Behringer or a Mackie, as cool as they are, well, they got too many knobs on them to go out on a remote. But this Pro Mix 4 from Broadcast Tools has that built in. And there's other products from Broadcast Tools that work with this. You want to check this out. It connects to this thing called the AHR1 Plus headphone system. and that can let you have really loud, powerful headphones for your talent that may be a little hard of hearing. You can also hook multiple ProMix 4s together, or hook it to a ProMix 1 unit with standard Cat 5 cables. Also hook it to a ProMix Hub 6. You get the idea here. This is well thought out. It's not just the ProMix 4. What you want to do is get online and go to broadcasttools.com to check out the ProMix 4. By the way, it also has individual headphone levels. How nice is that? You don't get that with the cheap consoles. Yeah, with the prosumer ones. So, check this thing out. You can also go to Broadcaster's General Store to see more about it, to get your pricing. Check it out there. At Broadcaster's General Store, remember, they're a sponsor of This Week in Radio Tech, so be best to support them too. Give them a call, 352-622-7700. Yeah, I memorized that years ago, 352-622-7700, or go to the web at bgs.cc. Thanks, Broadcast Tools and BGS, for sponsoring This Week in Radio Tech. Grady, years ago, it must have been 20 years ago, I heard about this revolutionary antenna that looked like a funnel that was going to revolutionize AM radio, and I didn't see anything ever come of it. And I thought, oh, well, another promise not delivered. However, in the intervening years, somebody's been working on this. Am I talking to him?
We're not the only people, but we're the people that somehow got funding that would maintain itself all the way through the process. This is not something that is predicted by the numerical electrical code. This is not something that the physics that we've been working with allows you to get to after having worked with it. It's a new approach. It's a different kind of physics, but it conforms to the laws of physics of the universe. So it took a while to get there. Everyone who's tried to develop this antenna has run into not having enough money and not having enough time to do it over and over and over and over and try something different every time. And in America, of course, the FCC never allowed anyone to experiment with it within the continental United States or any place else that they govern.
Our producer's having a little bit of connectivity issues, so let's take the photos and diagrams as we can here. For those of you who are listening to the podcast, we'll have links to these photos in the show notes, so be sure you look at that. But we're talking about something that, if you're usually a listener to the podcast, you may not, be able to easily visualize what we're looking at. So let's take a look at that at that picture again there, Suncast. This is a diagram. Tell us what we're looking at here, Grady.
What you're looking at is an antenna that has two driven elements. It does not require a buried ground system. It does not require guy wires that extend beyond the edge of the platform, which is over the little transmitter building. It fits on a single family dwelling plot of land. And of course, like any other antenna, it varies in height depending on its operating frequency. At the center of the band, it's about 65 feet tall, including the platform. Down at the low end of the band, it becomes difficult to manage because there's a lot of mass and a lot of wind load up above. But at the higher end of the band, it gets quite short. As a matter of fact, we're in the process of designing and building one to go in Atlanta, and that one is going to be less than 50 feet overall tall. And the city of Atlanta has told us, well, if it's under 50 feet tall, you're pretty much on your own.
Wow. So I'm thinking that there are a lot of stations that are the AM stations that might be a bit distressed that are on those local frequencies. What were those class 4 frequencies? Things like 1340. I'm sure you know all the frequencies, but I've worked at a couple of 1340s certainly, and some of those local mom and pop stations may be distressed. They may need to sell their land that the tower is on. And go for a smaller plot of land. And you're saying this can be a solution for that.
Kirk, you are a very perceptive individual. It is so much fun to talk with you because I don't have to say half of the stuff I'd be saying to most folks. You're exactly right. Our market right now, obviously, for medium wave broadcasting in America is not new broadcasters, because there aren't going to be any new ones. It's all folks that have problems with their land, problems with their tower falling apart, and the zoning board won't let them put up another tower, but they'll let you keep your tower as long as it doesn't fall. So when the thing eventually turns into a rust ball, you're basically off the air unless you can come up with an alternative. There are some other low profile antennas that work very well for the people who offer them, but all of them are taller than this, and all of the others do in fact require a buried ground system of some size. One of the reasons that this one is not really believed by most people is that it just doesn't make sense that you could make something work without a buried ground system. But it's a 3-terminal antenna. And it develops the magnetic field with an element, and it develops the electric field with an element. And the phase angle between the two is not exactly quadrature. It's not exactly 90 degrees, but it's at something that's not 180 and not 0, and we have to control it very carefully. And since we're not driving something against ground, we're driving two elements that are very, very close together against each other. The mutual impedance of those two elements has more to do with how you drive it than anything else. And I think that may be one of the things that other people who have tried to develop this antenna missed, or maybe they understood it, but they never figured out how to get to it. So in 2000, you and I were probably at the same NAB convention when Mars Haitley and Fathi Kabari did their presentation, and everybody laughed at it. And I went to the back of the room and I picked up the paperwork and said, why is everybody laughing? Do they think they know everything there is to know about the universe? And so it just kind of stuck in the back of my head. And in 2010, I got a call from somebody that I hadn't worked with in 30 years. And he said, we have some investors, and Mars Haitley's patents have run out on the antenna. So anybody can build the antenna. We've got some investors who would like to see if we can figure out a patentable method of driving that antenna and make it meet FCC minimum efficiency. And you know me, I was just really interested in that. So I spent 2 years working part-time for those guys as basically their field engineer in Webster, Massachusetts. But, you know, I kind of ran out of ego a long time ago. And I have a lot of good friends. And so I called up the people that I trust. I called up Kurt Gorman at Phase Tech. I called up my friends at Broadcast Tower Service here in New England. We brought them in, and we worked ourselves silly. We built 4 of these things, and the 4th one worked. The first 3 were built on a little wooden platform up the hill, and I purposely built it around the tower that we took down. Oh, I should probably step back a little bit and explain that the way we got the FCC to let us do this is we made a deal with a local small market, mostly daytime AM. It ran like 8 watts at night, to let us do this with their license. And then when we went to the FCC and said, well, we have this licensed facility and we'd like to experiment with this new antenna technology, they gave us an experimental license to do so. We had to put up a long wire antenna that we operated with for 4 or 5 years as we failed to get this antenna to work well. But then, and I want to say 1996, that's about the time that we really started to get it to work. Kurt had spent a lot of time out there, and he had spent a lot of time back at his office in Pennsylvania, doing computer work and stuff like that. And he finally came up with something that works well enough to meet FCC minimum efficiency requirements. He did a proof. He submitted it. The FCC accepted the measurements, and they issued a license in July of last year. So this thing's been on the air with a license, operating full power since July of last year.
Wow. And I was going to ask you about the FCC approval on this design because, they're pretty much have always approved the vertical radio, the quarter wave, and the quarter wave, ground radials to meet a minimum efficiency for getting the signal out. So this is
Right.
meeting a similar efficiency. Yeah.
It's a similar efficiency. It meets the minimum efficiency requirement, which is when you try to transmit with a series fed monopole that's about a fifth of a wavelength, you're right at the minimum efficiency. It was hard to reach that at first, but once we got to the point where it sat on the Smith chart right, and we figured out where we were, then we could start manipulating the way that we were driving it to get the magnetic field up so that the electric field would have something to propagate with. Let me find myself here. At a 90-degree angle through space. And once that happened, it was easy to do minor tweaks to it. Getting to that point was what took Kurt a long time.
And that sounds like it was the very, very difficult part. I'd like to, for those people who are viewing the show, we have a video, a 3D video to show, and I'd like to show that and have you talk about that, Grady. And I really would like to delve a bit more into the theory of the magnetic and the other. Anyway, I'd like to understand that a bit better. So let's have that video and have you narrate what's going on here. Suncast, if you could roll that video. What are we seeing?
This is a site in the south part of Atlanta where they lost their tower site, and it's a radio station that was performing a lot of community service for an underserved community, 10,000 watts daytime and some very low power at night. And someone bought the license without a site to operate from. They're in the process of building a temporary antenna. I think they're working with Burt Goldman to get that done. And this antenna, this is the second location that has been chosen for it. The studios and offices will be in the building that is just to the right as the video first starts. The building has been completely emptied and it's being refurbished right now.
So, wow. I wonder if, there we go. So there's the transmitter building with the antenna on top. Can you help me now? I know something about RF, leaving a tower, but gosh, can you help me understand what is actually going on with that metal ring at the bottom, the flat plate, and then
there's only so much there's only so much that I'm allowed to release at this time, and I will tell you as much as I can. If you look at this, the drawing is gone.
All right, it'll be back. Let's see. Suncast, let's put the drawing back. That's a good place to start here with this.
All right. If you look at the drawing on the right-hand side, you see something that looks like a small block building with a double door on it, but then it's got these legs that go up at the corners and in the center, and that supports a platform. The platform has on it a ground plane. The ground plane is what the other two elements are driven against. And that is how we achieve the approximate quadrature drive that has to go to the other two elements. The top element, many people have seen the old antenna that looked like this. The top element is called the E cylinder, and it generates mostly electric field. And the down underneath it, but above the deck of the platform, you're looking on edge at another piece of metal material that's basically flat, donut-shaped, and has a particular size. And that forms a capacitor with the ground plane on the deck of the platform. And the current that it takes to charge and discharge that capacitor by virtue of a form of displacement, the name of which my 71-year-old brain can't remember right now, it creates a magnetic field. And the key to making this work is to use that function with the E field that's coming off of the top part of it and have them work together to create an electromagnetic field that forms about 1.5 to 2 wavelengths away from this mechanism.
Okay. All right. In a traditional quarter wave radiator, vertical radiator, are the two fields formed right away there at the radiator, or do they also form out a bit?
They also form out a bit, but it's interesting with the antenna that we're working on. We believe that we have a certain amount of separate control over the magnetic field that's generated and the electric field that's generated. And the
Mhm.
difficulty has always been understanding how to control it to get the ratio and the phase angle correct. Uh, Go ahead.
Yeah. Wow.
I saw you start.
I'm going. Wow. Yeah. My brain is cranking on this pretty hard. Did you have equipment that can measure those fields separately and out away from the antenna and help you determine when you're in the ballpark with, and I got to know about the ATU for this thing. I guess that may be a secret, but what can you say about that?
We don't even try to measure them separately in order to
Mm.
tune it up. Let's go back though. You had asked how this compares to a monopole. With a
Mhm.
monopole, if it's a series fed monopole, it's basically sitting on a ceramic coffee cup, and you shove a voltage into the bottom end of it, and the voltage flows up the tower, and then that creates a field that is collected by the ground wires according to traditional theory, and
Mhm.
and that field creates the electromagnetic signal. The height of the tower has to do with the efficiency of the overall signal, and you get the best efficiency at just under a half wavelength tall. But think about that. A half wavelength tall tower in the middle of the band is 500 feet. That's a
Yeah.
big, big piece of steel. And if you have it 100% guide, that means that your guy wires are at a 45-degree angle. And that means that the guy wires occupy a space that is 1,000 feet in diameter. That's a
Yeah.
bunch of dirt. Um,
Yes. Yes.
and as you make the tower shorter, you lose efficiency. And I have my own seat of the pants theory. And remember, I haven't been to college. That's why I hired Kurt, right?
Kurt
But
Gorman. Yeah.
yeah, um, I have this seat of the pants theory that the tower is creating electric field more than anything else, and the magnetic field that ends up being created almost kind of happens as a side issue. And the shorter the tower is, the less of it you have, and so the electric field doesn't survive to propagate very far. Now, that's
Mm.
all just, that crazy preacher's kid sitting here thinking he understands this stuff. But I've been kind of right with some of my ideas, at least in the big picture. The thing that we think we have now is the ability to control that magnetic field and that electric field, and make the ratio closer to what it needs to be so that we don't have to have as much steel in the air.
Gotcha. Okay. All right. All right. One question keeps popping in my head. What about the bandwidth of this? Can this is this broadband enough that it's not hurting the AM signal?
All right. Our bandwidth measurements, without any special work on bandwidth flattening, using networks that rotate things a certain way on the Smith chart, and then put a series resonant trap in series with it to kind of pull in the side bands. Those kinds of things can be done. We have not had to do it yet to have a
Hmm.
good sounding AM radio station without digital on the air. Just standard network topology, but of course to drive two elements instead of one, and get the phase angle and the power ratio correct, has been enough to make it sound pretty good. As a matter of fact, there's enough high end that it matches very nicely an Omnia AM processor that doesn't have the bass rolled off a lot.
Okay. All right. Good. So
And
I'll
that
tell
is
you what
what's
we're
on the air,
gonna.
by the way.
Yeah. Well, thank you. Thank you. And is that the station in Atlanta, or is this the other one that you did?
Oh, we only have one on the air. It's the
Okay.
one that's in Webster, Massachusetts. We
Gotcha.
invite anyone who wants to come visit. to go for a tour, drive the signal with us. It's pretty easy to do. It's 12 miles south of the Mass Pike, and it comes in real clear on the Mass Pike for about 8-10 miles, which isn't bad for a kilowatt.
Yeah, it's a kilowatt station. Okay. Tell you what, we're going to take a break here pretty soon, but when we come back, I want to hear about some of the practicalities of building this antenna. I'm sure you got some proprietary stuff in there maybe you can't talk about, but this looks like it's a little difficult to put up. You can't exactly go to Home Depot and buy all the stuff you need for this, right?
Well, no, you can't, and we'll talk about that when we come back.
Okay, all right. You are listening to Grady Moates talk about the HEBA, the High Efficiency Broadcast Antenna. If I've got that right, if I don't, Grady will correct me when we come back. This is that design that you saw years ago, and now it's understood. It's characterized, and they know how to make it work. And the FCC has said, okay. So it's got some real advantages for AM broadcasters, especially in the real estate department. Our show is brought to you in part by our friends at CalRec. We'll be right back.
CalRec's Type R is a modular, expandable IP-based radio system featuring 3 slimline panels, a fader panel, a large soft panel, and a small soft panel easily configured to give the operator full control. Layouts are saved and recalled quickly between shows. A single 2RU core with integrated I/O gets customers up and running fast, and that single core can power up to 3 independent mixing environments with no sharing of DSP resources. Available in 4 DSP packs, and as your station grows, larger packs can be added, enabling it to grow with you. Power to the surface is supplied via standard PoE switches, keeping cabling to a minimum. Type R is fully AES67 compatible, as defined by SMPTE 2110, which means that it is also compliant with NMOS discovery and connection management specs. All these features combined make Type R the most flexible radio console you can buy. Find out more at calrec.com/TWiRT.
Thanks a lot to CalRec for sponsoring This Week in Radio Tech, and go to that website, calrec.com/TWiRT. Hey, if you're the kind of person, and I know Grady is, who's used a lot of these Studio Hub adapters, you may have found out recently that the folks at Radio Systems have closed their doors. And Studio Hub cable adapters, the ones that go from like XLR to RJ45, they're no longer available. Or are they? My friends at Angry Audio have basically bought everything. They're making the exact same adapters that you've been used to in the exact same factory, and the same people are running the equipment and making the adapters. That's right. They're available from your same broadcast dealers. Call your favorite broadcast dealer, order some more of these. Now they got the Angry Audio name on them, and they're available in the traditional one with the female the female RJ45. They're also available in the ones that have the male RJ45 connector at the other end. And those are typically in 6-foot lengths. And you can get those with all different kinds of connectors on them as well. And they're running a special right now at Angry Audio. If you buy the traditional kind, like this one right here, that's the one that I got started with, and a lot of my radio stations are wired with these because they plug right into Radio Systems consoles and all their goodies, but they also plug in to Axia stuff too. With that RJ45. If you buy this right here, this adapter, and you ask for your free cable, they'll send you a free 7-foot Cat5 cable. Not this one. This is 1 foot. They'll send you a free 7-foot cable with it's already terminated with RJ45 connectors on it. So they'll do that for free. Yeah. So check that out. Now's a great time to buy these. And you know what? Here's the other cool thing. If whatever you're used to paying for the old Studio Hub adapters, well, they cost less now from Angry Audio. The exact same adapters cost less. Now's a great time to stock up. So call your favorite equipment dealer or go to the website. We just saw it a minute ago. Go to angryaudio.com, angryaudio.com, and check them out. Everything you need. There'll be lots of gizmos that we've talked about here on the show and other things, but these adapters, not new, they're ones you're used to, are available right there. I'll be buying some soon as we build more stuff at my radio stations. Thanks a lot, angryaudio.com, for sponsoring This Week in Radio Tech. And don't forget your free gift of a 7-foot cable for every adapter you buy at a lower price. All right, it's Kirk Harnack here. Chris Tobin is indisposed. He had to go do something this afternoon, run a show. And I'm talking to Grady Moates, man that I met a long time ago. I always had great respect for. And when I saw that he was doing this HEBA antenna, Grady, what does HEBA actually stand for?
Oh, you got only the third word wrong. It's broadband, not broadcast.
Good. Okay.
Now, let me just talk about that for a minute, because I believe that practical information is a lot more important than formulas and that kind of stuff. This radio station is running with a Harris Gates DAX 1. It's the same transmitter that they had before we started working there in 2010. They were running into a 185-foot tower at 940. The FCC had granted a license for that. It's minimum efficiency, but it's because the station is on the same channel as a Canadian channel, and we have to protect that station in Canada, even though they're not on the air because of the international agreement. The antenna was so bad, that tower was such a high Q load that shifted from summer to winter and wet to dry, that 2 or 3 times a year, somebody would have to go out there and retune the ATU to keep the transmitter from burping. That's how bad it was.
Yeah, sounds like a short tower on 980. Yeah.
Yep. We are still running with the same DAX 1, if you can believe that. And I've had a lot of people go visit, and I took one of them out there in January of this year. There was 4 inches of snow and ice on the top of the deck and on the D plate. And we walked in there, and my heart was in my throat thinking, well, it's going to have a significant amount of reflected power. And that transmitter said 999 watts forward and 2 watts reflected.
Oh, goodness. It didn't change reflected at all, really, did it?
Well, it's a tiny bit. It varies maybe 0.1%. But the important thing here is, let's go back to what I was talking about earlier. We're not driving an antenna against ground using its self-impedance in free space. We are driving 2 elements in approximate quadrature, right, that are very, very close together. And so the mutual impedance of those 2 elements is what you're driving. Now, why would snow and ice really affect that? It doesn't. We are blown away by how stable this is. The owners of the radio station that's the first thing they will tell you, that it's been 2 years since they've had to touch the ATUs. It just runs.
Now, you used a phrase in there. You said the D plate, as if I know what that is. Is that the big copper thing at the bottom?
I had described it when that drawing was up. Once again, if you want to get that drawing up for a second, I can really describe it carefully. Look at the right-hand side, go up on the block building, and then above the block building, you'll see something that's about the horizontal width of a row of blocks. That is the edge of the platform that the ground plane is on. This particular one is copper, but we have built them with aluminum, and we know they will work. Now, just above that, you'll see a ring that you're looking at on edge that's being held up by little legs. And I can't see the dimension there, but in this case, it's, 16 to 22 inches tall. And that's holding up the D plate. Okay.
There we go. Yeah. A little close there. I can read D plate now. So you have the top of the deck of the steel, and then you have the D plate above that. Is that dimension pretty critical? Between how high the D plate is?
It is extremely critical.
Mm-hmm. Okay.
Now, if you could slide over to the right, you could see the nominal dimension of it. Over on the right-hand side, that particular one is about 2 feet on its bottom edge above the deck, but it's something that we adjust. Okay.
And then, all right, what's the funnel thing? How is that contrived?
The funnel thing, called the E-cylinder, is also on insulators. This one is made out of stainless steel 2-inch diameter tubing that has been bent to the proper shapes in the Phase Tech factory in Pennsylvania and shipped up there, and it was assembled on site. All of that stuff gets kind of welded together by people that know what they're doing, and then it gets set up on top of the insulating legs. And then there are guy assemblies. We don't like to call them guys. I call them sway stays. And they attach just below the point where the cylinder starts its flare.
Yeah.
And there are 8 of them, but they go to the corner of the deck. They don't go to the ground. So everything is self-contained on the platform.
This particular one shown here, what the overall height is 37 feet. Is that right? That's the height above the roof.
Above the platform. Yes, these dimensions are for Atlanta.
Yeah. What frequency is
Atlanta
that
is up. I think they're on 1480. I want to say.
Okay.
I haven't retained it in my head. The one in Webster's on 940, so it's quite a bit larger. That one is 72 feet overall in height, but the platform is actually higher than we would normally build them. And the reason that happened is because we're right up against a 200-foot hill, and we wanted to try to completely decouple ourselves from the local earth so that the hill wouldn't distort the pattern. And this thing is omnidirectional within like a quarter of a dB. It's hard to believe how omnidirectional it is.
Well, actually, based upon the fact that you say it doesn't depend on the earth for its operation, that kind of makes sense. And if that's true, could a radio station be on a piece of granite and have this thing work well?
We believe that it will work just fine. As a matter of fact, in New England, we have granite very close under the dirt in most of the state, which is why if you look at the conductivity maps that the FCC provides in their rules, you'll see that our conductivity is much lower than it is in the Midwestern states or the South. And a side effect of that is that summer to winter, AM propagation drops to almost half in the summer what it is in the wintertime.
Now, an antenna like this launching the signal, that wouldn't change coverage based on conductivity, would it?
Well, now you see, we haven't proven that. We've made measurements in both summer and winter, and we've found that the difference between the summer and the winter readings are not what we expected. But there's other stuff going on too. The people who own the radio station have told us, and it didn't occur to us to ask them, they said, one of the things that we've noticed is that when we're driving out around the fringe of our coverage in places where it used to be real dropouty and intermittently noisy, it's more solid. Now, I can't make claims based on that. It's something the manager of the station told us, and this has been supported by other radio stations in the area for whom I work. They've noticed it too.
Wow. So what we talked earlier, and I speculated, well, stations for whom, their property is more valuable, to a condominium developer. Talk about, the scenarios that AM stations could really, save themselves with this kind of situation. I built a 50 kilowatt daytimer in Memphis, Tennessee, years and years ago, and it was way out in the boondocks then, but not anymore. There's development all around it, and I can imagine them selling off a good 5 or 10 or acres or so, and just retaining enough to put an antenna like this on it. What is that a good scenario?
That is one of our major markets that we feel like we have strength in. Anyone who has either lost their site because the land has become so valuable that the owner of the land is not willing to renew the site lease for another 50 years for the same rate. So they want to quadruple the amount of money the station is paying. And with the way the economy is going and the cash flow that AM radio stations are generating now, especially in medium and small markets, they just can't pay that kind of money. So that is one place where if they can put their antenna on a small plot of land not too far away that is maybe environmentally challenged to the point that a dwelling or a commercial building can't be built there, but an antenna can still be placed there without upsetting environmentalists, then that is a perfect business model for someone to want to use a HEBA. Another one is if you have a tall tower and you own the land, and it's in an area such as you just described that was way out in the woods when you built it, but now the city has grown out and grown around it, and you could develop that land and make more money off of that land if you develop it than you can with a big tall tower and a big ground system and a 40, and 100% guy for your tower. You can now put it on a corner of the land, and you can set it up so that it's got enough space away from everything to not be affected by it and it not affect those things. And you can develop easily 3/4 to 7/8 of that piece of dirt and use it for something else.
At the lower end of the band, how big would one of these things get? You said that at 940 it was about 70 something feet tall.
It's going to be close to 100 feet.
Yeah. Okay. Yeah. What about lightning? Have you experienced with lightning hitting this thing?
We haven't had any transmitter failures at all since we got this antenna working. When we were working on it very early on, we discovered that, well, actually, it's something I figured out. Excuse me, I do have an ego. Well, I didn't know that. The transmitter was kind of constantly cutting out, but only under certain circumstances and only after it had been on for a while. And finally, what I figured out is that one of the elements didn't have a DC path to ground because of the construction of the network that was feeding it. And so the wind would blow and the air would be dry, and the element would get a static charge on it, which would add to the peak voltage when the RF waveform went in the same direction, and corona would happen, and the DAX1 transmitter would go ouch, and it would shut down because the current caused by the corona discharge was telling the reflected power circuit that there was a problem.
Interesting. So could you add a static drain choke to fix that kind of problem?
That's exactly what I did.
Okay.
I love talking with you, Kirk. You get it.
I was born at night, but it wasn't last night. All right. So the standard procedure there on the static drain choke. So if I were to go look at the station that's on the air, and I looked at the antenna tuning contraption box that's got, I guess, 2 outputs, one for the D plate and one for the what'd you call it? The E cylinder. Would I be just flabbergasted, or would I go, oh, well, it doesn't look so complicated?
I could not show it to you without an NDA.
Okay.
But it's not that it's complicated. It's just that it's not what you would expect. And it's important that the secret sauce be kept secret. Sure.
So, wow, that might be hard to keep those secret if they go out to lots of radio stations. Is it under lock and key, or is it potted, or?
Most people look at something like that and they don't really know what they're looking at. Think about it. This product is selling for less than what it would cost you to put up a quarter wave tower with a 100% guy wire system and a full ground system and clear the dirt to do it.
Yes, I was going to ask you about the cost, and you've got to compare it to the total cost of the whole tower situation, including clearing and ground system. Because again, no tractor putting out 120 copper radials to make this thing work.
That's right.
Wow,
that's right. What we have is only ground rods at the base of the platform that we attach to ground in as many places as we can, basically wherever there's a leg around the periphery. And all that does is it's a safety ground. So if there is a lightning strike, it has some place to go. We haven't had a lightning strike. Where we are right now, like I said, there's a 200-foot plus hill very nearby, and it's got trees all over it. So we're not in an area where lightning is likely to strike.
What about its use in something other than a non-directional? Is there any chance of incorporating this into a multi-tower array?
My third patent addresses that. It has been filed.
Okay. All right. But for now, we're looking at single towers, which, most of the class 4s that I spoke of earlier, a lot of stations that are distressed are single tower stations, maybe at a lower power.
Correct. As soon as this becomes accepted by the industry, not just by the FCC, as soon as the industry stops laughing, which is what they've been doing ever since, you and I were there in 2000. If you were in the back of that room, people were not being polite. We believe that as soon as the industry starts to take it seriously, there will be a lot of people that have business issues that we can help them solve. And then we're going to have trouble keeping up with it just with the business model targets that we have identified.
It's kind of interesting the way you said that. I guess you can look at this as a technical solution to a business issue.
Absolutely. If you're about to, let me give you the final issue. Everybody says, well, why would you put a lot of effort into keeping your AM? And the answer is the FCC, in the process of trying to help save the AM band, allowed FM translators to be tied to AM radio stations. And the license says that if the AM goes off, the translator has to go off also.
Yep.
So you have to keep your AM going if you want to keep your FM going. And as soon as many of these stations got their FM translators, their audience shot through the roof. If they had a programming model that addressed a niche in the audience that was not being served and they marketed it properly, now all of a sudden they've got a product and they need to keep that FM on the air.
Yeah. A lot of translators doing pretty well, making some numbers. Hey, we're going to take a quick break, Grady, and we'll come back with a final thought in just a couple of minutes. Our show is brought to you in part by the folks at Lavo. We'll be right back.
There has probably never been a better time in history to buy a new radio mixing console. Today's consoles are more sophisticated than ever, with more features and functions than you can shake a stick at. But have you noticed how complicated they are? There's a sea of knobs and switches and displays and buttons. Some of them look like you might need a pilot's license to do your show. Well, a board doesn't have to be complicated to be powerful. Just look at the new Ruby mixing surface from Lavo. The first thing you notice is how smooth and streamlined it is. Ruby has lots of cool tech, but what it doesn't have is that confusing ocean of buttons that clutter things up. Now, we all know that there are some console features the jock only uses once in a while, so why dedicate controls to them? Ruby fixes this problem by moving those once-in-a-blue-moon controls to a touch-sensitive, customizable GUI that happily shares screen space with your other studio software, helping you fight control room clutter. Thanks to this design innovation, talent that use Ruby produce smoother shows with less errors. Controls that are used the most fall naturally to hand, while functions that rarely need adjustment are easily controlled with just a couple of clicks in the context-sensitive GUI. And Ruby has cool features you won't find on other boards, like Auto Mix, an intelligent gain writing function that guarantees the perfect mix for multi-mic morning shows and call-in segments. Dual mode snapshots that instantly switch the motorized faders between on-air and production modes. And enough DSP and I/O options to make even your pro sound pals green with envy. And because quality is as important to Lavo as it is to you, every console is proudly built to fanatically precise standards at Lavo's own factory in Germany. If you're ready to declutter your control room, do yourself a favor. Check out the new Ruby and the other cool Lavo radio tech at www.lawo.com/TWiRT.
Thanks a lot to Lavo for sponsoring the show. Lavo.com/TWiRT. All right. Hey, it's Kirk Harnack along with Grady Moates, and Grady's with loudandclean.com. You can look him up there and see his technical services, including audio processing adjustment. And if he can get to you, he will. I'm going to guess he's pretty busy. Grady, the website about the HEBA antenna looks like it's worldwideantennasystems.com. Do I have that right?
Yes, that is correct. And it's pretty easy to find. There's a certain amount of useful information there. You get more information, though, by contacting Shane O'Neill at the telephone number that's on the website. You can also contact me. I've prepared much of the information that he distributes. So if you want a technical discussion, I can give you that. If you want to talk about costs, business model, things like that, I'm not the person to talk with.
During the break, I was also thinking about a little different problem that gets solved with this antenna, and that's the problem of migratory birds and them, dying near tower sites. Some people say it's a thing. Some people say it's not a thing, but it's definitely not a thing with the HEBA antenna.
Well, it happens that I was out there this morning because, it's hurricane season coming up, and I just wanted to go out there. Once again, I had our tower guys go out there and do an inspection to make sure that it was still in good shape. And here it is. It's been up for 3 years, and it's still perfectly plumb. I can't believe that. It's perfectly plumb, and it has non-metallic guy material. Some of you might have heard of it as Philly strand. That's the product name of what's actually holding it up. But I was pleased because the manager was there, and there were several big birds flying around. And he said, "You know why they're flying around up there?" And I said, "No, why?" And he said, "Because your tower guys are up there on the deck inspecting it, and normally they would be sitting on top of it looking for food in the field."
Yeah, what a great perch to look for. Oh, if it's a bird of prey, if it's a raptor, it's looking for a mouse.
Yeah.
Wow. Hey, give me the call letters again of the station that's got it on the air.
WG, F as in Frank, P as in Paul.
All right, WGFP, and that is in what town in PA?
Webster, Webster, Mass.
Oh, Webster, Mass. Sorry, Webster, Mass. Okay. All right. We're gonna we'll have a couple people already asking about which station it's on, so we'll get that information out. Going to put a lot of stuff in the show notes, and Grady, this show will post in the next 24 hours or so. So we'll have it we'll have it on, and we can point people to it on YouTube or on my website.
Excellent. I would like I would like to take just a moment for a final comment.
Yeah.
There's some thanks that need to be handed out. Number one, thank you to Kurt Gorman for having the faith to actually give this a try and not just dismiss it out of hand, because remember that Thomas Edison had to make over 600 light bulbs before he got one that would burn all night. You just can't give up fast, and you can't just decide that something can't be done because you've been told that it can't be done. You really have to follow the road all the way to the end. Second, I'd like to thank our investors. Our investors have been incredibly patient over this long period of time. And let me tell you, when we turned the corner in like 1996 and had an antenna that worked, and all we had to do was measure it and file it, and we could have a license, it was a long road that they had to go over also. So there you go. There are my thanks. Our tower guys used to be Broadcast Tower Service. Now we're using Luke Willis, who has taken that company and is operating it himself now that Broadcast Tower Service has closed its doors. So there you go. Thank you to everybody concerned, and signing off now.
Well, we'll put the links to the company and to you in the show notes, and people can get in touch there. And all right, we'll get all that in there. Grady, thank you so much for your time and being here and giving us this technical scoop on this. I really appreciate you.
Glad to be here.
All right, and thanks a lot to Suncast, our producer. We had some technical issues at the beginning of the show, and actually he's been working through the whole show a little bit handicapped, and I really want to appreciate Suncast for doing such a great job. You hardly knew he had a problem, and we got through the show anyway. Thanks a lot also to Andrew Zarian, the founder of the GFQ Network. We got to go right now. We'll see you next week. We'll be live from Dallas at the NAB Radio Show next week on This Week in Radio Tech. Bye-bye.